Good afternoon, ladies and gentlemen. Today I will present you my talk on seismic data acquisition using multi-component vibrating source and Landstreamer on York University campus, preliminary results, by myself, Barbara Dittiker, and Kevin Brewer. In the plan of this talk, we will present you as an introduction how this seismic reflection survey is designed to support an implementation of a multidisciplinary aquifer thermal energy system, a technology that uses near-surface aquifer. We'll have an introduction on our seismic data acquisition system. Then we'll jump on the York U survey acquisition preliminary results and focus on the Chimney Stack Road, which has an interesting potential for groundwater feature. And we finish with a conclusion. In this slide, I'm showing to you the simplest system of shear wave data acquisition, where we use a small sledgehammer that hits a plate that is fixed under the tire of a car, and it uses for recording a Landstreamer equipped with geophones, horizontal geophones. Then further in the time, we started to use a Microvibe source, which is much more powerful and faster in acquisition, almost 100,000 stations per day, very rugged, strong, unpolarized energy for bad weather, heavy road traffic conditions. Here you see the top picture on downtown Montreal. The lower picture is in downtown Ottawa. This seismic source is a 7-ton IVI Microvibe with a mass vibrating in transverse horizontal orientation called H2 with 7-second linear frequency sweep from 20 to 300 Hertz. We use a Landstreamer with 3-component 28 Hertz geophones. This is unfortunately a rather expensive acquisition. The third seismic source that I'm presenting here is the Microvibe. Is the source that we used on this survey on the York University campus. Here the picture is taken on the campus. This is the Microvibe. This is a vibrator, 2000 watt vibrator, mounted on a commercial transducer or bass shaker. It has 25% of the energy of the Microvibe. The acquisition is slower. It generates much higher frequency, implying a much better resolution. Generates a better polarized signal, possibility of 9-component or less per pass. Here we did a 6-component. That means we shook in vertical mode for the P wave and in transverse horizontal mode for the S wave. And then we used the Landstreamer, 72 meters Landstreamer, with the receiver at 1.5 meter and the shot spacing at 3 meters. This picture shows you the acquisition system, and to the right you can see the equipment, the seismographs, the gears during the acquisition on the road. Here I'm showing you example of a record that has been acquired on the campus with in the shear wave. on the left you can see that this record is very noisy. It has high frequency noise and low frequency noise. In the upper spectrum we see some peaks in the spectrum that are related with those noise due to various machine electromagnetic fields and whatnot, so we had to restrict the band. Once we filter out the noise, we center on the signal and we get a record like to the right with beautiful reflections showing up. The upper one is related with a major reflection which is attributed to the Newmarket, top of Newmarket Hill, and the lower one is attributed to the lower till just present over bedrock. In this part of the slides we can see the P wave. P wave has also some noise, but it's much more coherent even without the filter. To the left you see the raw record, and to the right the filtered record with again those two main reflections. Those arrows will be present in the next slides to show you those main reflections. This slide displays time in function of velocity, and we can see on the first arrow the top of Newmarket, high velocity, can be calculated at a depth approximately of 29 meters. Then the top of the lower till is at a depth of 72.5 meters, and the last picked reflector, which should be the bedrock, is at approximately at 80 meters. This measurements was taken on the Ian MacDonald Boulevard profile. This is the map of the campus, where we see 3 lines that have been acquired. First, the chimney stacks, 0.8 kilometers. The first line we acquired was quite noisy, windy, and there is also the power plants that were giving noise, but it's an interesting section. Then the Ian MacDonald Boulevard, which is 1.9 kilometers long, gives very good results too. And then the Tennis Canada. We won't see that section. The P wave was not working as there was some construction beside the line, but the shear wave gives some results. On this slides you can see on the upper section, which is a small section of the Ian MacDonald Road section, that the S wave is much higher resolution and much more continuous than the P wave in the lower panel. The P wave requires more processing, so at this stage it's not completed and much more complex, as the S wave is much straightforward. Now we shall have a look at the Chimney Stack Road section, which is processed in P wave and S wave. This is the raw P wave sections of the Chimney Stack Road, which shows on the upper part a sort of trough feature which is about 500 meters wide, and the migrated profile shows with more detail this trough feature. It's not as obvious as it is in the shear wave profile, where we have sort of diffraction at the bottom of this trough shape, or channel, if you want to call it a channel. That diffractions migrates very well with the migration tool, and shows a deeply carved feature, maybe filled with gravel or coarse sediments. The interpretation shows this trough in orange. The fill may be partially dimicton, sand, or gravel at the bottom of the trough. The other highlighted structures from bottom to top are in red, the bedrock, in green, the lower till, in violet, this could be the top of the Scarborough Formation. The stratification show maybe a Lakers twin sediment there. And then the top green would be the top of the Newmarket Till. The next section is the Ian MacDonald Boulevard section. It's a long section, so it will be quite squeezed in the profile. This section shows several features that I will highlight. With in orange the path of the subway. We have areas that are very high quality and I don't explain that at the moment, why some sections, some parts are lesser quality. Is it due to the subsurface coupling of the system, or is it effectively related with the structures in the subsurface? There is an area at the south end of the profile that may also intersect the channel that was crossed in the chimney stack profile. So it may be that we are following this this channel and crosses this profile too. We would need further profiles on other roads to trace that channel. In conclusion, we can say that this in-house developed seismic source shows a great capacity to image sediments down to bedrock in the Toronto area. It has a great potential to map aquifers in urban areas. In comparison with other seismic sources, this portable Microvibe seismic source, coupled with Landstreamer, has the potential to be a viable low-cost source for many applications in civil engineering and groundwater projects. Thank you for your attention.